Yeah, so let me say that the Sam, Kristie, and Jonathan book nicely connected with many themes and topic of the CHRONOS project, which is precisely about bringing together aspects from the metaphysics and the philosophy of physics, and from the philosophy of mind and the empirical oriented philosophy of experience, or let's say phenomenology. And the book is really seems tailor-made for sitting in this project, although it wasn't tailor-made because it was thought independently, but but also the book has a very nice connection with Silvia's PROTEUS project, and I'm gonna give the floor to Silvia for 2 minutes and before.
Even less, yes, exactly, Giuliano, thank you. I'm not only part with Giuliano of the CHRONOS uh, group, but also coordinating the PROTEUS one, the PROTEUS project. And with my research team, we are trying to assess the type of atemporality that is needed in some of the current approaches to quantum gravity. So, of course, from a philosophical standpoint, there is a genuine interest from our side on your work. And I hope that there will be, and this is maybe the first venue for a discussion that can fruitfully lead maybe to further, reflections, publications, collaborations, and so on. So thank you very much, Sam, for being here, and I'll leave it to you. Of course, if you need to ask me questions, also, especially people from home, if you have problems with the audio or something, just let us know, and I'll be sitting here so that I can check.
Thanks, Silvia, and thanks, Giuliano and Silvia, for organizing this event. It's great to be able to do this. Okay, so what I'm going to do is I'm just going to give a really brief, very high-level overview of what's going on in the book. There's a lot happening in the book. It's got experimental philosophy in it. It's got philosophy of science and physics in it. It's got metaphysics in it. It's got philosophy of agency in it. It's sort of a bit of a kitchen sink book. We just sort of threw everything we had at it and tried to make it all fit together. And with 3 people, the book was a year overdue. So we got there in the end. Can you just, is this going? Oh, it's all right. Got it. Yeah, no, I got it. Okay, so what we're trying to do is look at whether or not time exists. That's the basic idea. So there is a notion of timelessness that's talked about in philosophy, where people talk about the block universe or eternalism as being a timeless picture of reality. That's not what we mean. We mean the more extreme thing, right? The thing that McTaggart thought he had established, that time itself is not real. And there are, it's really important to be clear about what we're actually talking about when we're thinking about time and what the target of the book is. And so we differentiate between three different ways of thinking about time. So you can have a kind of folk notion of time. This is the everyday notion of time of the person on the street. This is the notion of time that Putnam argues against in his article that was mentioned at the conference this week. You've got a scientific notion of time, or scientific notions of time. These are technical notions of time that appear within specific theories or specific paradigms, or held by specific researchers. And then you've got various metaphysical notions of time, and these are some of the things that we've been talking about this week as well, things like the A theory and the B theory. And I think there are lots of different notions of time under each of these headings, right? So I think that the way that people talk about time is quite varied. Now, the focus of the book is on the top thing for the most part, the folk notion of time, right? What we're really interested in is whether the notion of time that people walk around with inside their heads, whether that thing is shown to, or could be shown not to exist in some sense. And I'll explain in what sense in a minute. Now, we focus on this for a couple of reasons. One of them is because we think it's what people care about. So there are various reified scientific or metaphysical notions of time. They're very important for scientific projects. They're very important for metaphysical projects. But there's a question about what kinds of notions of time people actually care about in their day-to-day lives. And we think of this folk notion of time. We largely think that people care about it because it's connected to notions of agency. So specifically moral and prudential reasoning. So, you know, when you hold someone morally accountable for something, you're holding them to account for things that they've done in the past. When you plan for the future, you're planning for the future, right? Which has got all this sort of temporality built into it. And when people are thinking of themselves as agents, self-conceiving of themselves as agents, we think they're using some notion of time, right? And it's whatever that notion of time that we have in our sights. But we don't just focus on this notion of time. We also think about how it relates to scientific notions of time, how it relates to metaphysical notions of time. So there's all of these other notions of time are in the mix, but this is the thing that we're primarily focused on. The loss of these other notions of time are interesting. So, you know, you might discover that the A series doesn't exist, for instance, but we think that actually that's not going to be so worrying for most people in their day-to-day lives. And we've got some evidence that actually supports that. So one way to sort of think of this project is to think of it by analogy with another project that happened in metaphysics to do with color. So there's a debate about whether colors exist, and that debate intersects with science in an interesting way. So the way that I understand that debate to have gone is that people had a folk concept of color. Roughly, a color is an intrinsic property that inheres in an object. And color science showed us that there weren't any such things, right? That's basically how that panned out. And so we have this sort of color anti-realism or color fictionalism arising. And that's really the kind of thing that we're interested in. Okay, there's this notion of time, that's this everyday notion of time. Can you have the same story about time that people have held for color? Okay, and so what we do in the book is a sort of very defensive book in some sense, and it's a very weak claim that we make. The kind of claim that we're interested in making is just that time might not exist for some sense of mind. So we're not arguing that time doesn't exist. We're just trying to show you that it might not exist. And the way that I think about the book, which might be different to the way that my co-authors think about the book, I'm not entirely sure, has to do with whether or not you think the existence of time is a priori. So I have heard, in fact, very recently, in as recent as the last month, someone started talk with, I'm going to take as my starting assumption for the metaphysics that space and time exist a priori. And I think that this is, like, I just don't see why we should accept that time is a priori. And the bulk of the book is just trying to argue that we shouldn't, that it might not exist. That if time exists, this is going to be an empirical discovery that we make about the world. So the book looks deeply metaphysical, like, and in some places might look kind of, you know, anti-scientific insofar as we're not just doing physics or not doing deep philosophy of physics in some places. But I think of it as incredibly naturalistic because we're trying to get rid of an a priori truth. And I feel like there's nothing more naturalistic than knocking out something that people take to be a priori without any reason, right? Okay, so we think that there are three reasons why people might think that it's a priori. The book's divided into three parts, and we take aim at these three reasons. So the first reason is that you might think that the folk concept is immune to error. And so to give you a sense of this, think about McTaggart's argument that time doesn't exist and how no one took it seriously in philosophy for the most part. They took seriously that the A series might not exist, but no one really sort of took up the call that time doesn't exist. And like almost because there was some kind of conceptual pushback where they're like, well, that couldn't be how things go, right? So it could just be that you can't actually make any discoveries about the world that would lead someone to deny the existence of time. So we argue against that. We also, the next thing we consider is whether time is required for science. So you might just think, like, to have a functioning science, you have to assume that time exists, and that's an a priori constraint on doing good science. We argue against that as well. And the third thing we look at is whether time is required for agency. So you might think that in order for us to self-conceive as the kinds of beings that we take ourselves to be, namely agents, you have to believe in the existence of time. And if we give up the existence of time, we'd sort of lose our sense of selves, right? And there's sort of, all of these are supposed to be giving you this kind of like almost Kantian argument in favor of the existence of time. And that's what we're trying to challenge. Okay, so I'll just go quickly through the way that we do this, then I'll pass it over. So the first thing we do is we do a bunch of experimental philosophy. We show that the folk concept of time is not immune to error. There are lots of things that you can present to people and they say time doesn't exist if that's true. We also discovered some other things along the way which you might be interested in. Folk notions of time are super diverse. There are lots of natural A theorists, B theorists, and even C theorists in the world, people who believe that something like a C series is the nature of time. There's about a 2/3 majority in favor of the A theory amongst people in the world. There's absolutely no agreement on what the best A theory is, but there is a general agreement that the loss of a C series, so the loss of any kind of temporal metric structure, basically the idea that you can have a sequence of things with temporal relations between them. If you lose that, you lose time. And one of the things that we point out is that appeals to intuition of the following kind, we should believe presentism because it's the common sense view, should be banned in philosophy of time because basically the evidence is against it. Yeah, Adrian. Yeah, not McTaggart C series. So this is the C series in the sense that Hugh Price and Matt Farr have talked about, where they so take the B series and then take the direction out of it, and you end up with a temporal betweenness relation. So A is between B and C. That's a temporal series, but it's not. It doesn't have a direction to it. That's all we mean. And if you lose that, then people will start to say time doesn't exist if you don't have that. I'm not going to go into the detail on the experimental philosophy. If you're interested, I can go through some of the details of the studies. The next thing we do is we look at time and science. So the basic idea here is to just arguing that the existence of time is not, that the existence of time is not required. So the non-existence of time is what they should say. So the non-existence of time is not ruled out by what we know from science. So there are scientific discoveries that we think you could make that would lead you to believe that time doesn't exist, or at least lead the everyday person to believe that time doesn't exist. And one of the tricks here is actually showing that science is possible without time in the sense that the everyday person thinks about it. And that's non-trivial because you have to show things like empirical confirmation, which is plausibly a pre-scientific concept, is still operable even without a notion of time that standardly underpins that concept. And that's hard to do. That's one of the things we argue for, though. I'll just skip over that in the interest of time. And then the last thing we do is we look at the challenge from agency. We have this little quick argument. If agents exist, time exists, agents exist, so time exists. And we argue against this by showing that there can be agents without time. And a lot of what we do here is, so one of the key moves we make is to show that you can have causation without time, and that we rebuild a lot of the things that people think you need time for using causal structure. And so one of the most controversial aspects of the book is the claim that you can have causation without time. I think you can. I think there are models of how to do that, but lots of people's sort of a priori intuitions are going to kick and scream at exactly that point. And so we spend a fair bit of time on that. And so what we do is we rebuild a sort of purely causal notion of agency that doesn't have time in it. And then we think about all of the sort of ways that people talk about time, and we treat that as a sort of shorthand for causal information. So you're allowed to speak about time. We're allowed to talk about being on time, being late, arriving at certain times. But it turns out that all of that is a way of compressing causal information into a manner that is understandable for humans, but strictly speaking false because it's an idealization of the true causal structure of the world. And that's it. That's what we do in the book.
Okay, so before I start, I just want to make a quick disclaimer. So one of the authors, Jonathan Tallant, is my supervisor, but he did not bribe or threaten me in any way to edit my presentation. So no. Okay. No, definitely not. Of course not. Blink twice if in danger. Okay. So I actually enjoyed reading this book. I thought it was quite fresh in a way, and the ideas are quite radical, but well argued for, even though I don't necessarily agree with the conclusions. So in the beginning, I just want to introduce the quick argument for timelessness, which is the main argument of the book, and see how it can be undermined in some way. So first, we have that according to several physical theories, the C series might not exist, mainly theories from approaches to quantum gravity, causal sets. And if we have a physical theory that says that the describes a certain situation, then this situation is a live epistemic possibility. And we conclude that we have a live possibility that the C series does not exist after all. Now, in chapter 6, which I'll be focusing on here, the authors talk about or introduce what they call the emergence challenge, which is to say, okay, what if, even if we have some theory of quantum gravity, which does not have space-time as fundamental, we can still somehow recover space-time as emergent. So by having space-time as emergent, then we can still get the C series, and therefore we can still get time. So the conclusion you have is that, so for any theory of quantum gravity in which space-time does not exist fundamentally, C series still exists by means of having emergent space-time. So in the work of this chapter, the authors consider several metaphysical relations that are supposed to do this work of bringing the emergent space-time back into the picture from the fundamental non-spatio-temporal reality. So they consider first two ones that they consider completely unpromising, supervenience and grounding. They move on to talking about three more promising ones, namely mereological composition, material constitution, and then finally, functional realization. Here, I just want to focus on one of these, which I believe is the most promising, actually. And I think that a lot of work, or some work, has been recently done on it in the literature in order to establish it as a way to cover space-time. So this is the relation of mereological composition. So first, the authors, when they discuss why composition fails as a relation to recover space-time, they consider classical mereology. So first problem we have is when it comes to inheritance of location. So the principle of inheritance of location, simply if X is part of Y, then Y is located wherever X is located. Of course, here we're setting aside things like weak location or exact location, because for our purposes, this definition is as good as it should be. So, but here's the problem. So if space-time, if we take space-time to be mereologically composed of non-spatio-temporal entities, then how can we have inheritance of location? Because in our mind, location requires space-time, or at least requires, or is defined in spatio-temporal properties or spatio-temporal terms. Also, another problem that we have, other than the inheritance of location problem, is that composition by itself, as the authors point out, is not enough or sufficient to carve out an object in the world. For instance, if we have a chair that has its legs as mereological parts, then that's not enough to say that it's a chair. These legs have to be arranged in a certain way, and they have to be a certain distance from each other, and they have to be certain angles. So if we have this chair and then two of its legs are pointing up, then it's no longer a chair, even though the parts are the same, physically, identical, but the arrangement is not. And so therefore, it stops being a chair and becomes a postmodernist art sculpture. So this is the second problem. And finally, a very similar problem is that the opposite also happens. So we have, in the same vein, how we cannot make out a whole from parts using only composition, we also cannot make parts from a whole using only composition. So back to the chair example, when we have a leg of a chair, then how can we know that it's a part rather than only if we can know it's a part only if it stands in certain relations to other parts. Otherwise, we cannot carve it as a part. Rather than, for example, if this leg is just 1,000 kilometers away, then I think we all agree that it stops being a part of the chair, even though the mereological sum is still identical to the chair itself without its leg removed and put into another continent. So taking into all these problems into consideration, the authors consider another form of composition that might do the job, qualitative composition. They follow the qualitative or logical composition scheme introduced by Laurie Paul in her 2002 paper, according to which composition or the mereological relations exist between properties rather than objects. So a chair is not made up of its legs or physical particles, rather it's made up of a mereological sum of its properties. So property of being red, property of being sturdy, property of being plastic, and so on and so forth, and weighting so and so. So this qualitative composition removes the two problems of arrangement. So we don't need spatiotemporal arrangement relations anymore, nor between properties, the same way we do as between material objects. The problem of inheritance of location still remains, though, and we'll see how it can be tackled later on in a few slides. So the authors then moved to consider some problems that plague this new alternative form of composition. So firstly, we have the problem of relata. So they say correctly, I think, that we need space-time points in addition to spatiotemporal relations between them. So we cannot just say that, okay, so the world is, so the space-time is made up of relations, but we need also points. And these points are not, do not appear to be reducible to properties. So they not appear to be properties themselves. So a reply that they suggest, potential reply that they suggest, is this can be somehow remedied by adopting another theory of Roy-Paul, which is the bundle theory from her 2012 paper, where space-time points would be at the top of a hierarchy, and then they would be composed of spatiotemporal relations, which are in turn composed of non-spatiotemporal fundamental properties at the lowest level. So again, we have space-time points, spatiotemporal relations, non-spatiotemporal fundamental properties. It's worth noting that similar work or similar account of this hierarchy of composition has already been being developed in the literature by the likes of Le Bien and Baron and Le Bien in their very recent paper in 2022. Another problem that the authors think, so as we say, we take the reply that the authors already introduced and we move on to the second problem, which is the problem of composite properties. So they say that, okay, if we have three levels of hierarchy, so we have space-time points, relations, and properties, how can the fundamental entities of quantum gravity, like spin networks or causal sets, possess these fundamental non-spatiotemporal properties that supposedly compose the higher level spatiotemporal relations without these fundamental entities themselves standing in these relations? To me, actually, this, and they give an analogy of someone who is both fast, both quick and agile, and say, okay, she's both quick and agile, so this means that she's also stealthy. So she has two properties. So if she has properties P and Q, and P and Q composed to make R, then she must have R. But to me, this kind of mixes the fact that we need, if in the case of space-time, the individual fundamental non-spatiotemporal possess, or like entities of quantum gravity, do not in themselves possess these spatiotemporal relations. So what happens is that they have the non-fundamental properties, which are the fundamental non-spatiotemporal properties, and then they need to be in a mereological sum in order for these properties to fuse. So the mereological sum of the entities is parallel to the mereological sum of the properties possessed by them. Otherwise, the properties are not, do not actually form the relations. So an analogy to that is that saying, for example, if we have a material structure, such as a table that's made up of atoms, so these atoms possess certain properties, like atomic mass and proton number. And the mereological sum of these properties supposedly gives us the higher level properties of having density and shape and hardness. But a single atom definitely does, we don't expect a single atom to possess any of these higher level properties. So I think a similar account can be applied to the space-time and the more fundamental entities that are posited by quantum gravity. So these more fundamental entities have non-fundamental properties, but they only fuse when they are in a mereological sum at the level of space-time itself. The properties fusion is tracking the entities fusion in a way. So this moves us to the third and final problem that the authors consider to be the strongest and the most hardest one to avoid for the account of qualitative composition, where they say that we get basically the problem of inheritance of location back from classical mereology all over again. Because space-time regions, which are composed of space-time points, which again composed of spatial-temporal relations, which are composed of non-spatial-temporal properties. This means that space-time regions are indirectly composed of non-spatial-temporal properties. But this creates the paradox where, but it's not a paradox actually, this violates the principle of inheritance of location, because now we have something that's non-spatial-temporal, so it doesn't have a location, that somehow composes space-time regions, which are spatial-temporally located. So how can we avoid violating such an intuitive principle like the principle of inheritance of location? So the authors also consider a model or a way of avoiding this problem by reformulating the principle of inheritance of location into something weaker, which they call weak principle of inheritance of location, or WELL, which states that if X and Y are both located and X is part of Y, then Y is located wherever X looks located. So here the trick is to introduce both are located. So inheritance of location can only occur if we have two entities and they both are located in a way. It's important here to introduce that the authors do not consider spatial-temporal location to be the only form or the only way to be located. So according to them, and I'm not a physicist to appraise this claim, so I'll take it at face value, location can occur wherever there's, in any structure, wherever there's a metric to calculate distance. So in a way, we can have entities located in a non-spatial-temporal way. But still, this gives us the problem that this solution of adopting will is contingent on the non-spatial-temporal fundamental properties being not located whatsoever. So even if they're located in some non-spatial-temporal way, this will still violate the principle of inheritance of location, because if we have space-time regions, they're located spatial-temporally, and then we have the fundamental properties, they're located non-spatial-temporally, then supposedly we would expect some inheritance to be one way or another. So either the spatial-temporal relations will trickle down, the spatial-temporal location will trickle down to the level of the properties, or the non-spatial-temporal location will rise up from the properties to the regions. So the authors think that this is enough reason to consider that qualitative composition as an approach fails, and they move on to consider other different approaches, which according to them, they also fail. However, I think that similar to the way we answered the second problem of composite relations, this problem can only be also be resolved very easily, and then we can still somehow say that qualitative composition is still a viable candidate and should be taken seriously. And that is reformulating well even further into very well the principle of very weak inheritance of location. So in well, we said that we have to have X and Y are both located. In very well, we have to say that X and Y are both located within the same structure for the inheritance to take place. So this means that within the case of space-time composition, we don't get inheritance of location, but that's fine because we now have very well to accommodate this, where if we have space-time that are regions that are spatial-temporally located and non-spatial-temporal properties that are located within some other structure, then we don't expect the inheritance to occur, and that's fine. Inheritance will still occur in our everyday uses of the term, because in our everyday uses, we only deal with spatial-temporal locations. So very well somehow removes this tension and between inheritance of location and space-time composition. And therefore, I think we should, this means that space-time is somehow back into the picture as a form of emergent entity that's composed of non-spatial temporal fundamental properties. So in the end, I think that more work needs to be done within the metaphysics of timelessness to fully dismiss this approach as a possible candidate to recover space-time and give it.
I wanted to talk about a couple different questions I had. I'm not so much, is it okay? All right. I think my concerns that I had are not so much an attempt at a takedown of their book. A lot of things I like, some things I had concerns about. but some of their series, their discussion of temporal series did leave me wondering what exactly they meant by temporal series and in relationship to mathematical representation. So I think that's kind of where I wanted to focus. So they give us these series, and I'm sure that many of you are familiar with them. So we have the A series that is sequenced by sort of past, present, and future. B series, we have earlier and later relations. C series, then we have relations without any preferred direction. And then there's also a D series. D series has no metric to it. You know, so I'm not really going at their argument and how they construct it, right, and build off of it, and I'm not going to try and get into all of the physics side of things, although maybe that would have been more interesting for this group. I guess the two questions I want to ask are this: what is the temporal sequence? So in the cases of these A through D series, they all have to be mathematized at some level, represented by math, right? And so I'm interested in knowing how it remains a temporal series once you've made it a mathematical representation. And I think this is maybe a hard question for anybody to answer when you actually get down to so I mean, it's not a particularly problematic thing just for Sam and Jonathan and Kristie. I think it's this broader question of how does time make it into the mathematics? What exactly does that mean to say that you've temporalized a component of your physical theory? And so that's the first question. And it leads to this broader question that I've sort of already woven in there. How does mathematics represent? And so this is a pretty well established space in measurement theory. And the reason I think it's particularly interesting to ask that question here is they're talking about physical theories and the sort of challenge of providing a sufficient physical theory that doesn't include one of these temporal sequences. And I suppose my puzzlement is it sounds like, you know, when we go and put one of these series into a physical theory, we're going to do something like develop mathematical structure. Maybe it's vectors and tangents. Maybe it's a one-to-one on a number line, integers or reals. I'm not real particular about how you're representing it for my question. Once you do that, I suppose to say that we want the time back out of the physical theory, I'm a little bit confused about that because it sounds to me like at that point, we've loaded our mathematical representations with a lot of metaphysical concepts. And so I think it would have been nice in the book to have a little bit more clarity about what's happening. And part of the reason I think that would have been really helpful is because of this further question of sort of distinguishing between our representation and the way the world actually turns out, right? And so it seems to me that it's actually fairly common for us to represent things and then think that the representation is in fact carrying more weight or saying more about the way the world is than it is based on so we start using our mathematics to derive other things, fine, but if we're not careful, it's actually we're carrying certain metaphysical concepts along as we go. It's not clear what it means to pull it out of the math or the physics all the time. Right? So in some cases we're talking about a number series or something like this, and I understand that you and I are doing the work of sort of supplying this. Right? But one of the problems is then how do you extricate it from a physical theory if it's actually the people engaging with the theory that are constantly supplying it? So I'm wondering what from the theory, what from the mathematics are you actually trying to pull back out? And I think that's a general question that sort of pops up every time we use mathematics to reduce or to represent a physical theory, or I mean, sorry, a physical system. So where's the line between our metaphysical concepts that we sort of overlay on the numbers and the the math? Because one of I suppose the worries that I have is that we could tell very different stories about a number of these structures, right? So I'm not sure, for example, Sam and Jonathan and Kristie, they reach all the way down quantum gravity to show that physics can support a timeless account of the world. But I'm not sure they had to reach so far, in part because I think the same question comes up about space-time and its ontological status. I think the reason it can is because it's been represented mathematically, and so now you have a question about how what kinds of metaphysical concepts and claims about existence and such actually carry over into the physical theory or the mathematics. I'm going to leave it pretty short at that because that's what I was really interested in knowing about. So I'm going to stop.
Okay, so we're going to have now Akiko's comments and then Sam's reply, and then the general discussion will start.
Okay, thank you for having me. Yeah, so I will mainly focus on. So first of all, I find this whole topic really fascinating. So I was happy to read, and I thought it was very clear and so nice to read. I'm not a philosopher of physics at all, so I mainly will focus here on what it would mean for action if there really was no time. I think the idea is that you can replace time or space-time or C-series with causal structure, which will then play the role that the C-series would have played. Before I come to the agency bit, I think a few things, just like some comments I should make about the causation bit. So definitely you need then causation without time to make that work. So one thing I didn't really understand is that you're like arguing, describing, like trying to argue for the possibility of simultaneous causation. That's kind of how you start by trying to make plausible these cases, like a cannonball on cushion, for example. And you have a time machine case, quite elaborate, which I thought wasn't quite as convincing, but that's a different point. But what I didn't understand about this is that, is it enough to say that there may be some cases in which we can accept simultaneous causation? Because I thought you'd have to convince us that all causation does not require time, not just that there may be some cases in which it's simultaneous. But then the other thing, dialectically, I didn't understand that you then swifted from talking about simultaneous causation to the idea that you can just come up with a new causal theory that uses Lewis counterfactual causal theory as a starting point, and then replaces space-time with ersatz space-time. So I was just a bit confused about the dialectic. What is it now? Do we like think about simultaneous causation, or do we think about replacing time with approximate space-time? So my problem about all this was just a bit, on myself, I guess. So I think that's quite central for everything else in the book to work. But I can't really tell if the physics here work or not. You're saying, well, we can posit some non-spatial temporal structure, which fulfills all the important empirical roles, which gives us a metric and some notion of distance and location sufficient to play the role so that we can still do empirical observation, confirmation, and all that. And this is very central for everything else to work. I don't know if it does. No. So take everything I say with kind of as a conditional. If that works, then then maybe I have some small other remarks, but yeah. Okay, and just a few more remarks about this in particular. I personally am a bit puzzled about the idea of non-spatial temporal location. So you're saying, well, it's an old philosophical idea. Think about theories in logical space or color in color space or Platonic heaven. And you're saying, well, there's a temptation to take that metaphorical, but we just want to take it literal. You know, what does that mean to take that literal? I was a little bit lost to have just a metaphor, so I'd be happy if you just, I don't know if you can explain it to someone who like doesn't know enough about the physics, so maybe if you tell me that, I'm happy to just shut up about it, but yeah. Right. Okay, so like one thing is that you yourself admitted in the book then that you say, well, all of this, even if you're saying, yeah, quantum gravity approximately realizes a metrical field of general relativity in the behavior of the structure posited by such by QG matches the behavior of the structure posited by GR and so on. But, you know, aside from the fact that I can judge about that, you also say it doesn't shed actually much light on what location essentially is a non-spatial temporal one. And I do think we need to hear a little bit more about this to see if your proposal about agency then works. All right, let me move on to agency now. You start with the conception of agency, which is fine. You like say, well, agency, we focus on deliberation. For one to be an agent, one must be able to impose a deliberative structure. So that structure is some things need to be fixed in the world, and on the basis of these things, you understand when you do certain things, there's consequences. Other things have to be open. That's the kind of minimal structure needed for deliberation, you're saying. So you need to at least believe in some such supportive ontological structure in the world. Some things you can't change, other things you can change. Only then it makes sense to engage in an action. Right? That's how you start a little bit, which is fine for me. And then you say, look, crucially, temporal thought and agentive thought, they kind of depend on each other. And that's the problem. If there is no time, not even in the minimal sense of the C theories, then all our temporal thought is false. And that in turn makes all our agentive thought false. That's a big problem. So then you discuss several ways out of it, right? As I understand it. Temporal realism, which would be, even if there's no time, our temporal thoughts are still true. You could think about it in a way that our temporal thoughts are made true by something other than what we think they're about. And well, the other thing, I didn't really understand the difference between non-aboutness realism and the other form, but that to aside, because you say these two options are not very interesting, not very liable, and I agree, so I won't say much about that either. What you then concentrate on is temporal error theories. That's the idea that you accept that because there's no time, all our thoughts involving times are simply wrong, and then you can go two ways. You can go eliminativist or fictionist. So eliminativist, you'd have to really eliminate all temporal thoughts from our lives. Right? Well, of course, again, you know, that carries over into agency. Temporal thought is false, so it's agentive thought. Temporal thought should be eliminated because it's false, and then, I guess so then should be agency. that obviously has catastrophical consequences for human life and actually undermines or what it means to be human almost. And then you say, well, but there's a sophisticated form of eliminative view, and that's to replace it with something that plays the same role, but is strictly speaking true. And you yourself list a number of complaints against that, and the most convincing I find here is what could possibly play that role. And also you say, how would be feasible to eliminate? But I really think the most glaring problem is what on earth could play the role to replace temporal thoughts, something that makes our temporal thoughts true, but is not itself time. So I don't know what you could come up with here. So, and then what you actually want to defend most is a form of temporal fictionalism. Temporal fictionalism also says our thoughts about time are false, but look, we shouldn't eliminate it because it's very useful for us in our life to pretend as if like these things are true. Admittedly, I also think that's the better option, but like as it stands, it has just the same problems. Like even almost worse, I find. You know, to you only pretend that these temporal thoughts are true. And because the falseness of the temporal thoughts makes also your agentive thoughts wrong, you kind of also only pretend to pretend. But the main problem is that pretension itself is a form of action. And so it's very badly self-undermining. But you have a fix for that, as I understand. Wait, where was it? Let me just see. I've got several things which are not so important. The fix for that you have is to say, well, we obviously need a supportive structure, like to make deliberation possible. And the supportive structure can instead, if there is no time provided by causal structure. And that's why I said like it's so important that the causation bit works. So again, the supportive structure is such that some things must be fixed and the other changeable. And so you're saying, well, causality, causal relations could take over that role because you might think things that are causally prior are fixed. You can't really do much about them, but further downstream, they're causally open. And that gives us this structure that allows us to engage in deliberation in a meaningful way. So because one sees a causal connection between eating porridge and feeling saturated, one decides on the basis of this to eat porridge to saturate hunger, basically. And now the idea is we can pretend that temporal thoughts are true because some agentive thoughts are true, and those ones involving causality. So this is more like I'm kind of summarizing it to see if I'm right in my understanding of it. Okay, but where I want to like my small objection maybe is then in the actual example you give on how that's supposed to work. So you have this example, Harry needs to go to the store in 5 minutes to get Hermione a present. Okay, so your suggestion is to replace it with, in order to get Hermione a present, Harry needs to get to the store. Him getting a present is causally dependent on getting to the store. And you say, well, that's enough to motivate him. You get the structure you need, so there's agency. And you say yourself, but what about the 5 minutes? There seems some urgency here, which is lost in the translation. And your proposal is to say, well, Harry can come to believe that if the clock is caused to show a certain number, then it won't be possible to buy Hermione a present. Okay, but I think there seems to be this analogy between the causal dependency of Harry getting a present and Harry getting to the store on the one hand, and the clock showing a certain number and Harry getting a present on the other. So why it's just hard to see how to generate the belief in the causal dependency of the letter without once time is taken out of the game. Why should there be a causal dependency between a certain number of a clock and his getting a present? It's only because we assume time in the first place before if we're taking out that, because if we're taking it out of the explanation, there doesn't, you know, well, it doesn't seem to make sense to think that there is such dependency. And also, if, like, here's just a thought that occurred to me after, I wonder if it's just causal that Harry gets the present. Is that really all what we mean with like volition and agency? So the idea is that I can deliberate because causation gives me the right structure, but it doesn't seem that I can choose to look at the clock with a number in order to go to the shop in the same way as I might choose to go to the shop, because I understand that this will bring about the state of affairs of me getting a present. So it seems to be this analogy here. So if I think about causal dependencies, yeah, it looks to me well, that's very motivating to think, okay, to get the present, I need to get to the shop because one, like getting to the shop will bring the other about. But seeing a certain number on the clock and leaving, it doesn't seem to have immediate, involve an immediate understanding that, oh, if I see a certain number, that will bring it about that I go to the shop, right? Unless I already assume, oh, this is time here, and if I don't go, I go too late. But if that's not there, where's the causal dependency that makes me want to go to the shop? Yeah. Well, and the last small point is, I was wondering, how does this all work if you're Humean about causation? I mean, you really need to take causation serious on your account, and it seems to me many more people find it reasonable to deny causation than to deny any form of time. And so, well, that's just a small point, but maybe that's also a little worry. Okay, that's it.
Thanks, Akiko. So now we'll give the floor to Sam for some replies and.
Okay. Thanks everybody, and thanks for reading the book so closely and for all your thoughts. I think I only knew what Britt was going to say, so I had no idea what the other two were going to say. So this is a little bit by the seat of my pants. All right, so I'll start with Yazam. So I'm going to just remind you of the issue here. So one of the points of the book that we discuss is the idea that you might believe that you might come to believe that time doesn't exist because you've got certain scientific theories that seem to have fundamental structure that doesn't have time in it, is the basic idea. And then the response to this, and I take this to be somewhat more or less the standard response amongst the philosophy of physics community and amongst physicists as well, is that, okay, although these theories might not have time in them, there's still some kind of emergent notion of time, right? So although the fundamental physics might not have time in it, you can still recover GR at certain scales or certain energy scales, and then you can still think that time is emergent. And we think there are two different kinds of emergence. One of them is a kind of theoretical emergence where you link different theories. Another one's a kind of metaphysical or ontological emergence where you link different bits of the world. And we have stuff to say about both of those, but Yazam was talking about the metaphysical one, the ontological emergence. And so one of the sort of questions here is, like, if you think about the way that emergence works in other cases, we've got a sort of stock of metaphysical tools that we use to understand standard emergence, right? So if I, think about the chair, in a certain sense, the chair is an emergent entity insofar as it's constituted by atoms and molecules, which themselves are constituted by subatomic particles, and then maybe by strings or whatever, right? And so we have these physical pictures of how this works. And if we think that space-time is real, or that time is real, and we think that it's emergent, then we should expect to have some kind of story of how this works. And one of the things that we're trying to show in the book is that it's really actually harder than you would think to see how that story is going to go. And there might even be a kind of explanatory gap of the type that you find in philosophy of mind, where you're trying to get consciousness out of some fundamental physical stuff, like, or some more fundamental physical stuff, and it's kind of hard to see how that's going to work. But the sort of breakdown that we see here is that with some of the metaphysical tools themselves. So it looks like Mariology, at least the way that some people think of how Mariology works, when you try to apply it to a level where you've got time and a level where you don't, the Mariological picture starts to break it down a little bit. And what we have in particular is a notion of Mariology that might be built on what's sometimes called Mariological harmony. The idea that the relations between parts reflect relations between locations or relations between objects and locations in some way. And this inheritance of location principle is one of these harmony principles. And you know, lots of metaphysicians are on record for saying it's an a priori necessary truth about Mariology, that, for instance, location is inherited. So Ted Sider is one of those people. Jonathan Schaffer is another one. Laurie Paul, in some moods as well, says certain things along these lines. And so what we're trying to show is that this sort of breaks down. Okay, and so then Yazin's response is, well, okay, the sort of inheritance of location principle that people have been using thus far breaks down, but there are others that you can supplement it with, and maybe they work too. And I think that that's basically right. So I think this is the right way to go. And I think you can even go further. You can actually just strip out Mariological harmony altogether. You can just break the tie between any notion of parthood and a notion of location and just stop having location be a constraint on parthood. And I think that that's perfectly fine. What the question that then arises, which I think is sort of an interesting question for metaphysicians to consider, is how useful is it in the end to use Mariology once you've done that? So what's nice about being able to take the standard Mariology that we have in metaphysics is we kind of understand how that Mariology works. We see it working in a bunch of other places. It gives us some kind of explanatory grip on the notion of emergence when we apply it. But when we sort of strip all that away and we just end up with a sort of like a really bare Mariology that's just a kind of set of mathematical axioms, which are not, like, they don't have a huge amount of content actually, and you apply that, although that's not what you were saying, the location principle is a bit more substantive than that. There's this question about how much you've actually clarified the picture, right? What we wanted to understand was how time comes out of something that's timeless. But if you apply a metaphysical tool that has had a lot of the guts stripped out of it that we were using to get an explanatory grip on the issue, it's not obvious that you've actually clarified the point anymore. So that's sort of what's going on there. I think that this is a good point, and I think that the way to go is to modify the Mariology, but you have to be careful not to, you want to end up with a Mariology that's still sort of useful. And I think this point generalizes. If you're going to try and understand the emergence of space-time and or time or whatever it is, you want that to be kind of explanatory, to give you some understanding, to be kind of useful as an interpretation of what's happening in physics. And so you don't want the metaphysics to sort of fail to be useful in that sense. And I have real worries because a lot of our metaphysics is sort of born and bred in a spatiotemporal context. And when we start to apply it here, it feels like it's sort of hitting its conceptual boundaries. All right, so the next was Britt. And I think Britt was raising two points, correct me if I'm wrong. So the first point was about what is a temporal series? And I think that this is a really good question, because if you look at the history of the debate, we've definitely changed our minds about what is a temporal series. So you know, think about the shift from, just in the last 100 years, the shift from McTaggart to post-McTaggart, the shift from the A theory to the B theory in some sense, but also the shift in relativistic physics where we go from Newton to Einstein. And we do both of those within like 50 years in some sense. And so there's this huge sort of conceptual shift around the way that we think about time. I think we just do change our minds about what we're willing to call time, right? So McTaggart thinks that the A series is essential to time. And so if you don't have the A series, then you don't have time. That's how his argument works. And we don't generally hold that now. And there's a similar move that you could make here, which is, okay, well, look, maybe you've lost some of the things that we thought were essential for time, but maybe we've still got enough structure to think that there's time left. And I think that you can raise that as a question about what's actually going on with what we're doing in the book when we're moving through these different notions of time and looking for them in science. But just more generally, I think there's this question now about, well, what do we think time is? What do we think, and not just time, but space and space-time? And how do we actually have a meaningful debate about this when we seem to be willing to shift our minds on the very notions at stake? in order to sort of preserve maybe intuitive pictures or preserve aspects of science. The other point I think that was being raised was about mathematical representation. And so, one of the things that we do in the book is we look at these physical theories, which have certain mathematical structures as the fundamental structure. And part of the basis for thinking that there's no time in these physical theories is because you look at the mathematical structure and it doesn't have, in a lot of cases, the mathematical structure of these notions of time that we are used to, right? So, for instance, some of them like loop quantum gravity doesn't have the metric field of general relativity in it. It's the mathematics is quite different. So you move from metrics on manifolds into nodes and lines, which are graphs. So that's a move from a continuous to a discrete structure, but it's also like a massive shift in mathematical technology when you do that. And they're using completely different mathematical representations. And they're doing that because the physics is like hitting serious mathematical problems. And so people are trying new mathematical strategies to try and make progress in physics. In the background here, you've got this question: when you've got a physical theory that's got a chunk of math in it, how do you interpret the math, right? Which bits of it are physically meaningful and which bits aren't? And this is an old and I think deep question about the way that we understand our physical theories. And I think that a lot of the discussion around the emergence of time or space-time, or the lack of time and space-time from these theories, is really bringing this into focus, because we need to try and work out which bits we want to be, think are physically meaningful and which bits we don't, and it's difficult. You also said that the problems, like, we reach down into quantum gravity to find the lack of time, but maybe it's already there in general relativity or even earlier. I think that's because you can make the same point. We don't know really what the ontology of a theory like general relativity is. We have a good understanding of mathematics, but it's kind of up for grabs what that tells us about the world. And even there, you could be anti-realist about the metric in general relativity if you want, at least in a metaphysical sense. As long as the math works, maybe it doesn't matter. Okay, so on to Akiko. Akiko, I think, was pressing in two places. One place was, and very usefully summarizing a bunch of the like connecting points. So you're totally right. I think you basically got the things we were saying. You're right that a lot of what we say in the third part hangs on the second part. If we're going to try and recover agency from causation, we'd better get causation, and it better not require time. So I don't exactly know what to say to sort of satisfy what you're finding unsatisfying about that material. But I guess one of the points you raised was 2 points. One of them was, okay, we say things like you can have simultaneous causation. Well, that sort of thing doesn't seem like it requires time in some sense, because it's kind of between spatial things. But is it enough to just show that you can have that? Does that show that you can have causation without time? That's what. So one question about that. And the other question was, what we do is sort of try and rebuild a theory of causation that doesn't require time, and how does that work? And then I think the dialectic relation between these two things. And I think there really are just two things going on here. One of them is a kind of defensive maneuver against someone who just thinks that there's an a priori link between causation and time. And we're trying to break that link with some examples, right? It's like, here's an example where it looks like that's broken. Here's an example, but that's not yet enough to think that you can actually have causation without time. Maybe we need to do a bit more work there. And so we build a theory that is based on a Lewisian theory, where we take Lewis's theory and we strip out all of the reference to space and time, and we use whatever structures we might have in a fundamental physical theory to sort of find things that play the role that you need to do that in the case of Lewisian counterfactuals. And I guess, like, there's a lot of detail in what's going on there, but at the end of the day, I think the idea is relatively straightforward. And the idea is supposed to be, you're still going to have structure, otherwise the physics is not really going to be very useful, I think. And the structure is going to be sort of rule governed in a certain way, right? So things will depend on other things. It's going to have like kinematic rules, it's going to have dynamic rules. And assuming that the physics delivers something like that, and the physicists or the philosophers who interpret the physics are right that it doesn't have time or space in it, well, even then, there's still enough structure to have counterfactual dependence. There's enough structure to have the kinds of things that, for suitably generalized notions of causation, might still count as causal, right? And I guess the thought is that space and time are not the only structures that there are. There are other ways of being structured, and some of those ways of being structured look like they're sufficient by my lights for causation. If you don't want to call it causation, that's fine. You can call it modal dependence or something like that, I'm not too attached to the idea that it's causal. What I am attached to is the idea that if you change something here, it's going to change something over there in something, right? Like, and then fill in the relevant somethings with whatever the physics says is going on at the fundamental level. Okay, so then onto agency, where you were asking about, so you got the sort of dialectic there. This is actually one of my sort of favorite parts of the book, even though I don't really work here. It's sort of, you think about error theories, and error theories in general, like a moral error theory, might take claims about what's right or what's proper or whatever, and say, okay, well, those claims are strictly speaking false, but they might be useful. And we can get away with that because we've got other prudential structures that we take ourselves to be realist about, which we can wheel out to make sense of what it is to engage in a fiction. But the problem is that the notion of engaging in a fiction itself seems to be this sort of agentive notion. And so if the thing you go fictionalist on undermines agency, then it looks like you lose the capacity to even engage in a fiction, right? And so like the sort of dichotomy that you have in moral theory between error theories that aren't fictionalist and error theories that are fictionalist seems to be like worryingly unstable here, right? And there's a real worry that there might actually be no good option in here. So, and then the way we recover it, as you noted, is we try and get causation, and we try and recover enough agency to then get in the fiction and stay there, so that we don't have to worry too much about time. So like not quite bootstrapping our way in, but that's the idea. So then the worry you had was about looking at different causal dependencies. Like, okay, so if I try and recover, I'm trying to get you a birthday present, and I want to get it 5 minutes before the shop closes, and I try and recover that in causal terms. I recover all of that story in a causal notion. You kind of get the sense of urgency. If I like look at the clock, and the clock causes me to hold the belief that I need to get to the store, and you can see how that gets me out the door, but you can't quite see how, like, without that, if I just look at the clock, why do I go to the store? Like, what motivates me in other cases or something like that? Is that the sort of idea? Yeah, good. Yeah, looking at the number might not motivate you to go out the door, but like, yeah. Yeah, so I guess my thought here is that we're trained in a kind of causal world as well, and we're trained to have kind of inductive capacities, and some of those inductive capacities involve like looking at clocks and then seeing other people look at clocks and do things, and like learning from what other people do, learning from causal systems. And I'm inclined to think I don't have a good story about how this goes. But there's some sort of like broader causal inductive story to be told about like past experiences of doing the sort of thing that you're interested in, that would then motivate you in those cases where it's sort of not obviously motivating. That story is not in the book, and I think you're right that something like that might be useful to you're right to press us to need something like that, and I think that's where I would go. Okay, so I think I addressed the main things. So we can open it up for discussion now if people want to talk about things.
First of all, yeah, rejoinders by the commentator. So
thank you, Sam, for the agreement, mostly. I just want to comment on the one thing you said about the conceptual gap between space-time and the non-spatiotemporal structure that you compared somehow to the hard problem of consciousness, to how there's a gap between the mental states and the physical processes of the brain. To me, I know this analogy already exists in the literature, but to me, I'm a bit skeptic about it, actually, that the case of space-time is similar to the case of consciousness. For one reason is that because in the case of consciousness, we have mental states that are completely not described by physics. So completely disattached somehow from the physical processes. They might be caused by them or supervened, but they're not described by physics. Whereas on the space-time case, what we have is space-time and another fundamental structure that's not space-time, but it's still physical. So even if there exists a gap, I don't see how it could be as big as the one that exists in consciousness. And therefore, I don't think that when we talk about when you mentioned how certain meteorological relations that are stripped out of their powers cannot do the explanatory work. I, for starters, don't think the explanatory gap is wide enough to acquire this amazingly explanatory relation. I already think it's not that wide, and I already think that for this reason, meteorological composition and in the sense of qualitative version would be satisfactory enough, because we already have cases where similar thing might appear in our everyday life. For example, when we talk about how, for example, quarks and leptons make up physical structure. So of course, they're both physical and they're both in space-time, but there exists a small gap in terms of the properties. So the macrostructure has several properties that the micro particles completely lack. So again, we can approximate that if this small gap, conceptual gap, can be closed by using meteorological composition in some form or another, then the slightly larger gap that exists between a physical but non-spatial temporal structure and a space-time might also be closed by the same or similarly conceived relations. So the case of the case of consciousness is on another extreme. I agree, it's a wide gap, probably not, cannot be closed, but the analogy between space-time and consciousness is not an accurate one in the beginning. So I think for starters, we need to stop this comparison in order to be faithful to the real conceptual gap that we're facing, which I think is not that wide at all.
Yeah, so I mean, I agree that they're not the same. So the hard problem of consciousness in part arises because you have two different theories: a folk theory of psychology, usually, or even like a proper theory in psychology, not just a folk theory. And you can't, according to Chalmers at least, it's not obvious that you can derive that from anything in science, right? And so, part of the hard problem for Chalmers at least is the failure of deducibility of the psychological level from anything in science. And so that's partly what's driving him to think it's so hard. In this case, it's a constraint on building an adequate theory of quantum gravity that it's going to be able to, imply general relativity, or at least approximate it to a high enough degree that the difference between approximation and implication is not, deduction is not particularly relevant for at least physical purposes. So I think that there's definite differences. I guess that being said, I don't think that the gap is quite as narrow, but I think it's interesting to have a conversation, like in general, for us all to have a conversation about whether and to what extent there is a kind of conceptual gulf here. For me, when I think about the world not having any spatial properties, not having any temporal properties, and then trying to rebuild those properties out of something that doesn't have it, I'm just at a bit of a loss as to what to do, right? Even when I look at these theories in physics, they're not giving me a hell of a lot to work with, it seems like, in terms of like physically interpreting this fundamental level. So I guess I think we just disagree about the relevant extent of the gap. But I don't think there's something we can settle. I think there's probably something we need to continue as a group to talk about. Yeah.
Great. So I have, yeah, of course.
This is not at all an objection anymore. Let me just try to, for my own understanding, make an attempt to spell this out, how it maybe works. So it could be like, I was wondering like, sorry. So I was wondering like, again, about this example, right? Oh, but, what can it mean to be too late for him to get a present? So here's probably what you could say how this works. So maybe you can say, Well, how you learn it is you learn that this number refers to some location star in your approximate space time, and that location X star brings it about that I will still manage to get the present location. Y star brings about that I won't. And then the temporal fiction talk, like that we like talk about it, that these locations are temporal locations, something like that. That would make sense then, and I can understand kind of it just works in terms of your ersatz locations, right?
Yeah, I think that would be one way to do it. I have the feeling that there's a way to do it without even using the ersatz locations, but this is a respect in which I'm more radical than my co-authors. So they don't want to get rid of that structure. They think that's sort of like, once we've lost that, we've lost anything that we can use to recover anything. But I think we can maybe even do without that. But I don't have the story. So I think the story you gave is the best story to give, given what else we say in the book.
Okay, thanks.
Yeah, so thank you. Okay, actually, I guess we shouldn't have switched it back and forth, but okay. Yeah, so I guess I had hoped maybe to pin you down a little bit more on what you all were conceiving in the book, because I thought it would be helpful for the rest of us in these other conversations. Because I guess what was worrying me was the ambiguity in how you all referenced, for example, these temporal series as perhaps numerical, perhaps reals or integers or a metric structure. And the reason this was worrying me is it seems to matter whether what I think, let's say, integers represent, right? And I don't usually confuse them with some temporal thing, right? So when does the time come in and how does it get there? And I guess that seemed, on the one hand, I hear you saying, well, maybe there's not a good answer to that. And I think we agree on that. But part of the reason it worried me was it sounds like even your D series might count as inappropriately metric because of the vagueness of how you define these temporal series. On the one hand, I take it by your D series you had in mind something like configuration space. But the way I thought that you used some of these terms was too broad. So in configuration space, we're still adopting a particular geometry, usually Euclidean geometry. And so there is a kind of metric. I agree it's spatial, so it's not what we usually think of as temporal. But I guess my worry is that the definition of these temporal series is too broad, so that on the one hand, anything might count as a temporal series, and on the other hand, you might never get it out of your physics. And so I guess I had that question, and that was partly related, and maybe the best thing to say is, yeah, there's no way to really sort out how we get time and space into our mathematics, and so maybe we just agree on that, I think it's related to this. Craig has made a similar point in some of his stuff about. I think he mentioned someplace in his book on time, this sort of in classical physics, we sort of have space and time represented by our vectors and such, and we sort of pick out vectors of zero for our space and positive ones for time, but there's a weird. It's sort of weird to say that there is space and time there, except that we've sort of put them out there. And so I guess I don't necessarily think we could solve it for everybody, but I do wonder how we can be sure that that we've arrived at well, yeah, how do I know when I've got it and I got it out of my physical theory? And I guess I was hoping, since that was so much the focus of the book, you guys might have a more definite sense of exactly what was doing the representation. And maybe your answer is just Britt already told you we don't, and that's that. But yeah, so I guess I wanted to sort of press you a little more for that because of the lack of distinction between, say, space represented by any set of, let's say, a vector, or time represented by. How would I know what representation was serving outside of what I sort of bring to the mathematical representation along the way? So I guess that's what I find a bit confusing, because when I press metaphysicians or sometimes philosophers of physics on this, you know, what is a temporal series? Oftentimes the go-to answer is, well, it's something mathematical. Like, okay, but then how would I get that? You know, if I look at the mathematical thing, it's not clear to me that it is temporal or that it is spatial. You know, okay,
I guess I'm not fully picking up on the issue. So I think there's a couple of different things here. So I mean, metrics are cheap. You know, a metric's just a function from some things to real numbers in some sense, right? That gives you, that obeys certain constraints, certain properties. And you know, you can find them all over the place, right? You know, the real numbers just have a metric over them that you can find just by mapping the reals back into themselves. And so you can, you know, get all kinds of things that are metric. So we don't think that like having a metric is sufficient for having time, right? I take it what's happening is that people think that there are physical distance relations in the world, and the metric structure of some of these theories represents those physical distance relations. And so we've got, you know, there's time as a physical distance relation in the world, and so, or space-time as a physical distance relation in the world, and then the metric field of general relativity, for instance, will represent those physical distance relations. But time is the physical distance relation. It's not necessarily the thing in the mathematics. We don't have to think of time as living in the mathematics, I think, in quite that sense. There's a question about how we know when we've got a mathematical structure that represents a temporal structure, or represents a set of or spatiotemporal structure, or physical distance relations, or whatever. And I think that depends on, you know, partly what we think these things are, like what it is to be space-time or what it is to be time. And I just think these are kind of hard questions. You know, I think what you think space-time is might depend, you know, depends on who you talk to. If you could be a functionalist and think that it's, you know, whatever plays this sort of inertial structure role, as we heard about in the conference. So yeah, I mean, I guess I'm not quite sure I see the issue. I think the mathematics might represent things that are temporal, and there's a question about how we know when we've represented something temporal, and there's a question about what time is. Yeah.
But I guess I've actually had conversations with metaphysicians where it does seem like they imagine it living in the mathematics. In fact, Jonathan will even say, well, you know, I think it's maybe time is just this really thin thing, like a mathematical structure. And so I guess that's my concern, is it's not clear that everyone's staying straight about the fact that time and space aren't living in the mathematics. It seems like a great reach to say, well, all I think about time or space is this sort of very basic representational thing. And I guess that's my worry, but fair enough. I mean, yeah, that's not true of everybody, clearly.
So we have Emily, Federico, Jack, Christian, and Graham. Did I miss anyone? No. So Emily.
So I'm wondering if we think that there's no such thing as space-time in reality, does that leave an opening for the Kantian idealist to say, great, this is how space and time come into the world. They're just, you know, forms of thought. And the question is a little bit less strange than it might seem, given that Ha-Seok Chang has recently defended a kind of Kantian idealism about reality. He thinks that our minds frame concepts, and everything we perceive and see is in light of those concepts. How do you feel about Kantian idealism?
I mean, what the thing worries about, I mean, I don't know that I understand Kantian idealism, right? But here's a version of it that I've heard, which is that for Kant, space and time and causation are conceptual categories that we use to order the empirical information coming in from the noumena to produce the world of it, the empirical world, actually, right? So the world that science studies is the world produced by the integration of the information coming from the noumena via our categories, right? So for Kant, strictly speaking, space and time don't exist because they don't exist they don't exist outside of the world of phenomena. They're not part of the noumena world, and neither is causation. And that last part, makes you wonder how we interact with the noumena. But I guess what worries me is that in some sense for Kant, space and time are a priori aspects of the empirical world, at least, right? Because you can't make sense of empirical information without some kind of spatiotemporal conceptualization of the empirical world. And this is like relates to one of the issues that's in the book that we talk about. So there's this problem called that Chris Vutrick and Nick Huggett have talked about, called the problem of empirical confirmation, and the problem goes roughly like this. If you've got a theory and it says that space and time don't exist, or space-time, whatever it is that you sort of think is doing that kind of work, well, then it's really hard to know how to make sense of empirically confirming that theory, because space and time, or space-time, are necessary preconditions for empirical confirmation to occur, right? So that's the sort of structure of the argument, and that's one of the problems that we're engaging with. And like that's one of the challenges of showing that it's not a priori that time or space-time exist, because you've got to be able to make sense of empirical confirmation without those notions. And that's why we think the notion of like time-free causation or time-free dependence of some kind is really important, because you're going to need that to rebuild empirical confirmation. So the sort of like the Kantian stuff is in here, right? So Chris and Nick explicitly, I think in one of their papers, or maybe it's one of Chris's other papers, he says something like, we don't really want to be Kantians about this, right? So we don't think that these things are a priori. But this argument is sort of like, we've got to deal with this argument if we want to avoid saying that sort of thing, right? So I think that there is this sort of worry about Kantianism of that kind in the background. That's certainly what motivates me. I think that whether space and time or space-time exists is like, it should be discoverable through science. And it's odd that they should be preconditions for how we do science. At least that would be a remarkable discovery if that were true, because it would drive us back towards something like some form of Kantianism, I think. Right. So I think I don't think that there's an explicit connection between the work that's going on in Kant, except insofar as there's something about the flavor of this problem which is Kantian, and something about like the avoiding the a priori, which is like resisting some kind of Kantianism.
Thank you.
Hi, thank you. I was wondering, so every time I hear talking about timeless causation, I start to worry about what is the ontological category of the causal relata at stake. So I was very curious to hear you talk a bit about your position about it, especially in the case of agency, because the only debate I'm aware where it is discussed where what could be like a timeless agent causal account are like theological debates where you have like discussion about how could God cause the the temporal world, and they are usually bounded to like substance causation. So they have like the agent substance that it's cause of whatever the first event, but usually the second relata is temporal. So I was wondering if you have any thoughts about it, and what would be your term?
You're asking about what the relata of the causal relation.
Yeah, and especially in the case of agency.
Okay, especially in the case of agency.
Yeah.
So I guess I think we're shading into things that I like, views that I hold that aren't necessarily going to be part of the book here, but I think that that's fine. So I think that what's going on is that you've got matter fields, and the matter field, I've got a kind of hyper-relationalist picture. I think that there are matter fields and they're coupling with each other, and it's the relationships between the matter fields, that these dependence relations between matter fields, that is giving us a lot of the stuff that we study in empirical science. And, you know, physics is a description of what's going on there. So I think that the causal relata are, you know, points in matter fields that are doing that kind of work. When it comes to agency, you know, we're just sophisticated chunks of matter, right? That's what I think humans are. I'm a materialist about materialist about the mind. And so I think when we're thinking of agent causation, it's just the same. It's more of the same, just at a higher level or lower scale, depending on how you think of these things.
Okay, so it's about, oh, I'll give you.
Okay, thank you. I might just push you to speak about something that we haven't really spoken about at all yet. So because of idiosyncratic interests, but also because it's in the book, I wanted to ask about the X5 that you were talking about. So one is just an invitation to say a little bit more about what there is there in the book. But I was curious with what you described about, I mean, you gave us the very, very broad picture. I know not all the details, but insofar as you give someone a vignette of a universe or something like that and ask people to judge whether or not time exists in that universe, and given that people, I think this was right, given that people can judge that, no, in that universe, there's no such thing as time, you took from that it couldn't be that time is one of these things which is just like immune to error for us. So I was wondering, I mean, given that I'm at least anywhere near accurate with that being what you're doing there, I was wondering how you're construing what the participants are understanding about the vignettes and the kind of questions that are going on there, just because of a general worry that people might have in these cases where people are reading these cases and they're looking at it and going, does time exist in this universe? And they might not have a space to call you out and say, look, I don't think that's a universe. But they might think, well, no, time doesn't exist because I don't think that kind of thing exists. So there might be space for someone to still think, well, what they're not saying is, yeah, there you've got a universe without time. I'll grant you that. They might just be confused about what you have there. Or insofar as they think you have something, be like, well, you're giving me a vignette, so I'm going to take that at face value, but do I really think that's something like a universe? Maybe not. I mean, I'm sure a lot of this is stuff you've already thought of and have figured out. Just, yeah. Any more on that? Great.
Yeah, I mean, I'm probably not the best person of this authorship group to ask about the X5 stuff, but you know, I have done it, and I am doing some at the moment as well. So I'm a bit more into it these days. So I have all of the same worries that you do about all of this stuff. I think it's, you know, runs through all of this kind of social science research where you go up to someone and you say, what do you think about this? And they tell you things, and then you take that as information about how they're conceptualizing things. The method that Kristie in particular developed, and all we do in the book is like really take the results from her lab and all of the studies that she did, you know, more or less do a meta-analysis of that, except without redoing the statistical work, and, you know, put that to work, right? So insofar as you read the bunch of papers that she's written on this, you know, you'll get the same kind of view. But what's, you know, what do these group, the sort of X5 stuff do to control for this? They have, you know, like comprehension check like questions, and so large amounts of participants are just thrown out because they're asked to whether they actually comprehend the thing that you've asked them, and it turns out they don't. But the ones that are left are then the ones that you test on. You know, run different versions of the same study to try and make sure that you're like, it's not an idiosyncratic feature of the study that is like triggering the response, and you look for the patterns of responses. But I'm sure I'm not telling you anything that you don't already know about how XFi and social sciencey type stuff works already. I guess I'll tell you what worries me the most about it. So instead of like helping you to answer your worries, I'm going to tell you what bothers me. The way that the thing is done at the moment is you give them a description of a universe, and then you ask them to consider whether the universe that we're in is corresponds to the universe that they've been given to describe. So it's sort of like you're supposed to take this description and imagine that this is the way that the actual world would be. And it's what's being asked of these participants can be quite cognitively taxing. And it's not obvious to me that like what's coming out the end of that is something we should trust. It could just be sort of like the general melting of their brains as they finish the study, right? And so we're doing follow-up stuff to check on this, to try and control for other things. You know, one of the things that bugs me is that they're asking about imagination, and there's all these individual differences about how imagination works for people. So I just ran a study on imagination and time to see if like individual differences in visualization capacity corresponds to what people think about time. And it looks like there might be some interesting interactions there, but we haven't like looked at the data in detail yet. So I'm with you. We've done our best, and I don't think I can tell you anything more than probably what you've already tried, you know, done with the Warwick group on this sort of stuff already. Yeah.
Yeah, sorry. So, I mean, I do share the general worries and skepticism. That wasn't the only thing I had behind it. It was more, in particular, thinking about this case, so how it ties to the immune through error stuff. So when you're asked, yeah, so I get what you said about you worry about just melting their brain when they're asked to imagine a universe and things like that. But just, we're going for the good case. They're understanding the vignette, they're answering it properly. Let's hope there's at least some of them. And they're saying, yeah, so I don't think there's time in that universe. Can you, just for the sake of going over it, because we haven't yet, run through the dots of exactly how that's tying into there time not being something which is immune to error? So even if we get rid of all the skepticism, it was just seeing.
Oh, I see. Sorry, okay, I misunderstood. Yeah, so the thought was that here's the hypothesis, and the hypothesis could be wrong. And it's like, you know, it's an operationalization of what it would be for a concept to be immune to error. And that is that pretty much no matter what you tell someone about the universe and ask them to accept that that is how the universe is, they will never, and you ask them whether time exists, they will just always say yes, right? That's the thought of what it would be for the concept to be immune to error. Insofar as you just can't get them to deny that time exists. And we got them to deny that time exists fairly stably across, as soon as you get rid of distance, but temporal distance, that's when people start going, I just don't think this has time anymore. So, you know, if you've got a world that's just got one point in it and nothing else, pretty likely to say that there's no time there. Yeah, so that I hope that helps. Yeah, yeah, and it could be a bad operationalization of that initial thought, right?
Yeah, it was just particularly on that point because I often worry about these things. So there's a distinction between asking someone to consider like a counter possible and say, look, counter possibly, does time, you know, in the actual world, does time exist if it doesn't have these features, versus sort of asking them like the indicative, you know, like if it turns out the world doesn't have these features, does it have time? And you might think, right, well, I just think that it's the most empirically well-confirmed thesis possible that we have time. Like, it just couldn't be better. I can't imagine what evidence would push back against every experience of my life in which there was time. But counter possibly, sure, if this were a world with features that the world clearly doesn't have, there would be no, I mean, so how are you distinguishing between the kind of the indicative and the counter possible there?
I mean, we were asking them explicitly to consider counterfactuals. And we did that because there are protocols supporting people's capacity to understand counterfactuals, and indeed to understand the distinction that you have in two-dimensional semantics between considering the world as actual and considering the world as counterfactual. People can track that distinction and they can make judgments about it. And, you know, so there's some evidence about this. So that's what we did. We didn't ask them the indicative thing. It's all explicitly modally framed. And the thought is that, like, if we're trying to get at their concept, it's, you know, again, thinking in this two-dimensional way, it's considering the way the world would be as actual that matters for getting at the a priori content of the concept. So.
I have no idea. Are we late? Should I? Okay. So I have two questions. That's why I wanted. May I ask both of them? Okay. So first, thank you. The presentation was really clear, and the more I know about the project, the more I like it. So thank you. So I think you know what I'm asking, and I'm asking about the inheritance of location stuff, mainly because I hope you're gonna spoil me something about your replies, the SMS. That would be great. So I was kind of like my first reaction to what I heard about your exchange was, I don't see why. So we should restrict the inheritance of location principle, right, to concrete entities, spatiotemporal entities. If it's unextended to abstract entities, it doesn't make sense. And I think Sider would agree, right? So if it's restricted to spatiotemporal entities, it shouldn't worry people that are trying to speak about emergence or whatever between spatiotemporal entities and non-spatiotemporal entities. So this is a slightly different worry than the one you know about in the paper. And I want to know what you think about that. It's just very naive worry. And the other one is, so not the other question, like again, about the inheritance of location. So I read the book yesterday on this part, because I was curious to see what changed with respect to previous versions of the argument. And I think, so you actually claim very specifically, and I think you're right, that Casati and Varzi have this like conditional reflexivity principle that basically allows you to claim that locations, locations are exactly located at themselves. But you know, it's not really like the received view. You can find people that deny this principle mainly because it has counterintuitive consequences. Among others, there can be two things exactly located at the same region, mainly the thing located at the region and the region. So the idea that locations are not located at themselves but are located nowhere, it's actually probably more useful than the one you use. So I wanted to know whether you considered this and about what you think about the inheritance of location restricted to abstract entities. Thank you.
Restricted to spatiotemporal entities, right?
Yeah, the restricted version.
Yeah. Okay. So first on the restricted version, I mean, this is a sort of a move you can make. You can say, okay, it's spatiotemporal entities only that the inheritance of location applies to. For things that aren't spatiotemporal, it doesn't work. You have to be careful though, because if it applies to any spatiotemporal entities, and they're made up of non-spatiotemporal parts, then some versions of the inheritance of location will push downwards, not just push up. So they will like push spatiotemporal properties down onto the fundamental structure. Depends on which version, right? So some versions of the Cider stuff, like the inheritance seems to be going in both directions. Parts inherit locations from wholes, wholes inherit locations from parts. And so if the spatiotemporal stuff is located at itself, the non-spatiotemporal stuff is not. The spatiotemporal stuff is made of the non-spatiotemporal stuff. Even if you restrict the locative inheritance to like spatiotemporal entities, you're still going to get like the inheritance pushing down, at least I think. But we can have a chat about that. The second thing about the Varzi stuff about the reflexivity of things being located at themselves, that sort of, so I agree that is like their view, and it's not necessarily the standard view or anything like that. It's and I think that you're right that if you give up that, then you can say that things are located nowhere. What I wonder though is if I actually don't know that this is an essential part of the argument. I think that you can recreate the argument just with things that are located in space-time and that are made of more fundamental things. And in that case, you don't have to worry about space-time being located at itself. You just have to have things that are located in space-time being made of things that aren't. So suppose you have something like the following view: every spatiotemporal object is non-fundamental, right? Then it's going to have some connection to some more fundamental thing. And whatever that connection is, if it's a mereological connection, then it's going to, the inheritance of location stuff is just going to apply to the objects directly rather than to the space-time itself. So my sense is that you don't need that principle, the Varsi principle, to run the argument. It's only if you're running the argument on space-time itself, but I think you can, you don't have to. I think you can run it on other things. There might be some other principles you need, like everything that's in space-time is non-fundamental would probably be, like every spatiotemporally located thing is non-fundamental, but I actually think that's kind of plausible, given, you know, the sort of physical description of things at that level. So yeah, that's the, yeah, okay.
Okay, so when you did the, I mean, I've not read the book yet, but when you did the précis earlier, you introduced this analogy with color, and you set it up as, you know, we started off thinking that colors were kind of primary qualities, and then we realized that there were no colors, there's just stuff that gives. And of course, one of the ways that that debate goes is people go, there are really colors, it's just that they're response dependent. And so we detect colors rather than project them, but we couldn't grasp what it was to be a color were it not for the kind of creatures we are with the kind of engagement with the world we have. And I take it there's an option in the case of time to make exactly analogous a move where you say, sure, so it's given the kind of agency that we have and the kind of causal things we have that we're able to make sense of these kind of temporal concepts. But that's not a sign that we're projecting this onto the world, but that we're detecting a feature in the world that we can only make sense of, given the set of practices that we're engaged in. And I was wondering if you had anything to say about whether you thought that there was a disanalogy there, or whether you thought that you had sort of argued against the detectivist position in your book.
I mean, we briefly consider it. Richard Healy actually suggests this quite early on in this debate. So he's one of the people that first identifies the problem of empirical coherence in about 2002, I think, about a decade before the Wüthrich and Huggett paper. But he frames it in terms of observation. He says, you know, like, how can there be observers without time? And he's focused on canonical quantization for general relativity. So he's also looking at different theories, different space of theories. But you know, people have had these worries about time since at least, you know, the first attempts to quantize general relativity in, you know, using the techniques that work for other quantum fields. And so, you know, he suggests this response dependent thing. He's like, okay, maybe time is like a secondary, and he uses the language of secondary qualities. You know, it's some relation between us and the world and something we paint onto the world. I think he calls it projectivism, actually. I think he uses the language of projection, which is again, like lining up with some of that color debate and maybe even looking back to like certain Humean theories about causation. We don't argue against it. I guess it's sort of lining up with some of Emily's thoughts about Kantianism, right? This view is starting to look Kantian in some sense, maybe, right? Like we add the time to the world, and you know, that means that sort of all our empirical study of the world is kind of like, yeah. I'm just not. I guess I elided the distinction because I'm not sure I understand it. But yeah, okay, fair enough. It's in the world in some sense. It's still gonna. I worry it's still gonna come out as kind of a priori-ish on these sorts of views. But that's my worry about them. I haven't given an argument, but that's my worry about those sorts of views. But we didn't argue against them in the book, so I think that's an option on the table to think about.
So yeah, the second point was more like, yeah, I'm curious about what you think about that. So I discussed this with Jonathan, and he's kind of agreed with me a few years ago, but then maybe he changed his mind. So I was like asking to him about a sociological question, or why people in the philosophy of physics community are using the notion of emergence as applied to space-time. It was just a curiosity. And I kind of assumed that there was some kind of deep reason for this, because in the metaphysics debate, the notion of emergence has kind of a specific meaning. There is a distinction between strong and weak, and it's really like something different from other notions. But then when it comes to space-time emergence, it seems that people are talking about a completely different thing that has nothing to do with the emergence in the metaphysics as used by metaphysicians. So, I mean, I know that then in the book you go into details of specific notions like composition and so on, but I just wonder why we keep using emergence in this context. What do you think about that? Why shouldn't we just start using a better word, probably? I don't know.
Yeah, I mean, I heard Paul Humphreys once supposedly said that emergence is a term that's escaped semantic control in philosophy. And so like I think there are just real worries about this word because I think it means all different kinds of things to all different kinds of people. And I think physicists use it in a different way. So as far as I can tell, and I'm sort of going on some stuff that Jeremy Butterfield and Chris Isham have said about this. When physicists talk about emergence, they mean something like, you know, at least some of the things they mean. I don't think there's a standard usage of it in physics either. Something like a theory that approximates another theory, right? And it's then they'll talk about the theory as being emergent. And you know, with some well-specified precise approximation technique. So, you know, if general relativity approximates quantum gravity at certain scales, well, then it's a kind of emergent theory in that sense. So I think part of the motivation for talking about emergence is that a lot of the philosophy of physics people are talking about emergence here. Some of the physicists are talking about emergence. And so there's a sort of desire to be continuous with the conversation. But I agree that like it's starting to become an unhelpful term here because you have all these different things that it could be. It could refer to the relationship between two theories in a strong sense, like derivability. Some people use it that way. Could be a weaker thing like approximation. It could be this metaphysical thing. And if it's a metaphysical thing, you've got different notions. Could be some combination of those things. Karen Crowther's got like this 3-stage thing about what emergence could take. I mean, it's starting to like get out of control. So I think it's probably better just to stop talking about emergence in this space, but it's probably too late for that now.
Thank you.
For us. I mean, it's not too late for you.
It's not too late. I mean, thank you.
Anyone want to some other question? Or?
Does this work? Okay. So I just want to address something that Christian has said before. So he suggested that maybe we should restrict the inheritance of location to spatio-temporal entities. So do you think that it's conceivable, at least, that we have composition between two levels of non-spatio-temporal entities? So, and where we would like to keep some form of inheritance of location. So we'd leave the door open for that at least. Yeah.
I do want to leave open the possibility that you've got inheritance of location between things that aren't spatio-temporally located. Yeah. But like, I don't really have very strong views about Mariology, I'll be honest. So if you want to give those up and have a different Mariology, that's fine. What matters to me is the picture sort of physically understandable and explanatory? Is it doing justice to what physicists are talking about when they're developing their theories? And is it helpful for the project that physicists are engaged in, which I think has got like deep conceptual issues that they're trying to wrestle with that I think we can help. Like those issues are more important, I suppose, than hammering home a particular metaphysical position.
Okay, so if nobody wants to add anything, thanks again, both commentators and well, thanks everyone for having been until the very end, and well, see you next year, hopefully.